Take an ice cube in your hand. At first, it feels solid and cold. Wait a few moments, it turns into water. Leave that water out long enough, and it slowly disappears into the air. Same substance, three completely different behaviors. So what actually changed? Let's go a little deeper. Matter exists mainly in three states: solid, liquid, and gas. And the difference between them isn't what particles are made of, it's how they move. In a solid, particles are packed closely together. They vibrate in place but don't move freely. That's why solids keep their shape and volume. Now add a little energy. In a liquid, particles still stay close, but they can slide past one another. That's why liquids flow, take the shape of their container, and still keep a fixed volume. But wait, here's the twist. Add even more energy, and the particles break free. In a gas, particles move fast, spread far apart, and collide constantly. That's why gases expand to fill any container and can be compressed easily. Here's something even more interesting. These behaviors are explained by kinetic theory. It says that particles are always moving, and the temperature of a substance is simply a measure of how fast those particles are moving. Higher temperature means faster particles. Lower temperature means slower particles. That's why heating a solid can turn it into a liquid, and heating a liquid can turn it into a gas. You're not changing the substance, you're changing the motion of its particles. Let's connect this to real life. Why does sweat cool your skin? Why does pressure build up in a gas cylinder? Why does steam carry more energy than hot water? All of these answers come from understanding how particles behave in different states of matter. Before we wrap up, zoom out for a moment. Matter doesn't change because it wants to. It changes because energy is added or removed. And once you understand particle motion, phase changes stop being mysterious. So the next question becomes obvious. If particles are always moving, how do pressure, volume, and temperature control gases mathematically? That's exactly where we go next.